Okay, let's try to get this done in 15 minutes or less. So, classifying matter and separation techniques. The first thing you should know is that matter is anything that has mass and occupies space. So, for example, the electron is the smallest particle that exists. Um, and even though it's very tiny, it does have mass and it does occupy space in the atom. So, it's considered matter. There are 118 elements in the periodic table. We need to know the difference between an element and a compound and a molecule. So, and we'll get into that in a bit. Three, different, just because you have two of the same thing doesn't mean that they're going to have the same properties. It all depends on the arrangement of these atoms. So if the elements in a compound or a molecule are arranged differently, then they're going to produce different properties. So small changes in the structure could dramatically affect the properties. Here's a question: is energy or radiation considered matter? So in chemistry, you're going to learn that, for example, gamma rays do not have any mass associated with it. So by definition, radiation is not considered matter. But people are arguing and saying, wait, um, light energy, energy that comes from the sun, light rays, for example, um, they have little particles. So how does it not have mass? It has to have some mass. It's just not measurable under a scale. So it has to have matter. So it's actually something that's very controversial. So if you look on Google, you could learn more about that controversy. So every time you have um, the same chemical formula or molecular formula. This is called a molecular formula. They have the same number of atoms, the same type of atoms. So two carbons, one oxygen, and six hydrogens here, and six hydrogens here. Same formula, different structure. One thing you need to know is that this is the molecular structure, and this is called a ball and stick model. What is the purpose of drawing this? So different atoms are colored differently, and these little sticks are called chemical bonds. So these are all single bonded. The purpose of a ball and stick model is to show the angles. So this angle here is gonna be smaller than this angle here, and this angle here is gonna be larger than this angle here or this angle here. So the bond stick model accurately shows the angles versus here the angles are all wrong. They're not, they're not shown correctly. Um, so um, what is an isomer? An isomer is when you have um, two of the same formulas but different structure. So same atoms but very different arrangement. So they're obviously arranged differently. The oxygen is attached to one carbon, but here it's attached between two. Um, because they're different in structure, they're gonna have different properties such as boiling point and melting point and solubility, how something dissolves. Three, if you analyze the boiling point, ethanol does not boil until it reaches a temperature of 79 degrees. So if you have a bottle of alcohol, which is ethanol, it's not going to boil. But if you have something like dimethyl ether, you bring it out into your living room, it's not going to exist as a liquid, it's going to be a gas because its boiling point is negative 24 degrees Celsius, very low. It's gonna boil very fast under room temperature conditions, room temperature being around 25 degrees Celsius. Here's another example of an isomer: same number of carbons, same hydrogen, same oxygens, different arrangement. Here you see a double bond. Again, a bond stick model shows the angles. What is this cis and trans business around here? What does that mean? So cis means that the atoms are in the same orientation. So if you slice this molecule in half, it will become a mirror image. So you'll see the same thing on the left and the same thing on the right. Here, however, if you slice this in half, you do not have a symmetrical representation here. So because of that, it's considered trans. So same number of elements, different arrangement is called an isomer, different properties. And this time we are introducing what is the difference between cis and trans. So cis means that the elements are on the same side, creating a mirror image, and trans means that they're on the opposite side, so they're asymmetrical. You should read through this PowerPoint slide, know the difference between a gas, liquid, and solid, and make sure you understand what pressure means. The more collisions, the more the particles hit the container, the more pressure it generates. Matter could be classified by whether something is a mixture or whether something is a pure substance. So, for example, salt is considered a pure substance. Water is considered a pure substance, but when you mix the two, it forms something called a mixture. If the salt and the water mix evenly, then it's considered homogeneous. But if they form layers or they're not distributed evenly, then they're considered heterogeneous mixtures. So the first thing you need to know is that pure substances never change from one sample to another. If you have CO2, it's in one spot, it's going to be the same as the CO2 found in another location. All substances could be elements or compounds. So you need to know the difference between a compound and a molecule. Compounds must have two different elements. Different is the key word here. Different, different, different. They must have two different elements. H2O, two different elements, H and oxygen, so it's a compound. However, molecules could have any two or more elements. So H2, for example, is considered a molecule because it has two elements. But this molecule, H2, is not a compound because it only has one type of element, hydrogen. So every single compound could be a molecule because all compounds have at least two elements. So all compounds are molecules, but not all molecules are compounds because not all molecules like H2 have two different elements. So H2 is both a compound and a molecule because it has two different elements, but H2 is only a molecule because it doesn't have two different elements. It only has two elements that are the same. They're not different. So make sure you know the difference. So mixtures, there's two different types of mixtures. Homogeneous solutions, they're evenly distributed. They look like one thing. Heterogeneous, they form layers or spots. For example, piece of wood, it has layers in the wood, so it's considered heterogeneous. Now, here are a few substances. You need to know whether it's a compound, molecule, heterogeneous, or homogeneous. So if you have a sample of acid, it's going to be a pure substance, so it's not going to be a mixture. It's not going to be any of these two. But because it has more than two elements, different elements, it's going to be a compound. But by default, all compounds are molecules. Cl2 is only a molecule because it has only one type of atom. And it's not a mixture because it's not mixed with any other pure substance, so it can't be hetero or homogeneous. Three, unreactive xenon. Xenon is one element, just one element, so it cannot even be it can't be a molecule because a molecule must have at least two. So this is not a compound, it's not a molecule, and because it's not mixing with anything else, it's not a mixture either. So it's just nothing. It's just an element. Coffee has different components into it. It has caffeine, it has water, it has different substances. So it's considered a homogeneous mixture because it's all dissolved together to form one thing. Wood has different layers, so it's heterogeneous. And air is a ball of different gases, so it's considered homogeneous. The law of constant composition. So the law of constant composition just says that it says that methane will always have four hydrogens to one carbon. The law of constant composition just says that you will always have the same number of elements in that compound for every sample. For example, I think that was a little confusing. So if you have 5 different samples of CH4, every single sample must have 4 hydrogens to 1 carbon. There's always going to be a 4-to-1 ratio. The mass is going to be in a ratio For example, water. Let's look at water, for example. Water will always be a 2-to-1 ratio for hydrogen to oxygen. If you look at the number of atoms, a 2-to-1 ratio. However, the mass could also have a ratio. So hydrogen has a 1-to-8 ratio, or actually 1-to-16. No, I'm sorry, 1-to-18 ratio. So hydrogen has a mass of 1 atomic mass unit, and oxygen has 18 atomic mass units. So there's a 1-to-18 ratio. So um, just know that the ratios are the same. So the ratio for CO2 is 1 to 2, the ratio for CH4 is 1 to 4, and there is a mass ratio too. So let's look at the notes. The law of constant composition is also known as the law of definite proportion. Elements found in a specific compound are always the same. So the hydrogen in one water molecule is the same as the hydrogen in the other water molecule. All samples of water will have 2 hydrogens and 1 oxygen in a 2-to-1 ratio. And 94% of the mass of water will be oxygen and 6% of the mass in hydrogen. And it will be the same for every single sample of water, whether you get water from California or whether you get it from another country. The mass of oxygen in water will be 94, and the mass of hydrogen will be 6%. You have to know the difference between physical and chemical changes. Physical changes are usually reversible. You can reverse them. For and there are evidences such as melting point, boiling point, hardness, shiny, soft, the odor, color change could tell you the difference between. It could be an evidence of a physical change. Chemical changes are when you break and form new bonds, and you have to break bonds. In physical changes, you don't break bonds; they're just rearranged. Okay, the molecules are just moving around. But in a chemical change, the bonds are actually broken and new bonds are formed, making new substances, and it's usually irreversible. Evidences include rusting, color change, temperature change. For example, it gets colder, it gets hotter. The formation of precipitate, meaning you're forming a solid inside a liquid. So you have a liquid, but then out of nowhere you form a little solid. That is called a precipitate. That little solid is called a precipitate. Okay, next PowerPoint slide. Different. There are different types of different ways to separate mixtures. The first one is called paper chromatography. Chromatography is the separation of a liquid mixture. It could be a dye, it could be blood, it could be urine. The most common one is urine and blood. It's a very common technique used in forensics. So, for example, here they're testing whether these horses were exposed to drugs right before a race. So, in spot number 1, they put a spot of caffeine, and the caffeine traveled upward in this direction. So, what happens is that you put this piece of paper, and then you put something called a solvent, which is a liquid or a gas that you put all the way to the start line. This liquid or solvent is going to cause different compounds to travel at different rates upward on this paper chromatography paper. This piece of paper. Um, so the first spot was caffeine. They put the caffeine here on the start line, and then it traveled up to 7.5 centimeters. And then they put paracetamol, which is a painkiller used for it's used in all our. Paracetamol is another word for acetaminophen, which is found in our Tylenol and Advil. Um, and it traveled here. And then they put urine samples of horse 3, horse 4, horse 5, and horse 6. Or horse A, B, C, D. So here, if you notice, horse A, it had no painkiller, and it also had no caffeine. So this horse was not exposed to any of these drugs. Horse 4, not exposed to paracetamol. not exposed to